In this problem, we're given some information that the sine of A is greater than the sine of B, and that they're both positive, and we're asked for 5 statements to evaluate them as to whether they're always, sometimes, or never true. Let's go through them one by one. The first one is sometimes true. By that I mean there are certain values of A for which this is a true statement, A and B, I should say, whereas there are certain other values for A and B for which this is a false statement. And to show you my logic, watch these diagrams. In this diagram, we'll see that our given statement at the top is true. The sine of A is greater than the sine of B. You can interpret that as the blue line is taller on A than it is on B. That represents your sine. And it is also true that the cosine of A is less than the cosine of B. So this is an example that shows that the statement can be true. The fact that it is true can be represented by the fact that the red line of A is shorter than the red line of B. That's how I'm thinking of it. But here's a counterexample to this statement showing that it can be false. Notice that in this case, the given statement at the top is true. The sine of A is still greater than the sine of B, interpreted as the blue line of A is longer than the blue line of B. But the statement itself is false. You'll notice in this case that the cosine of A is greater than the cosine of B. Look at the red lines to see that. The cosine of A is represented by a positive number, yet the cosine of B is represented by a negative number. And since a positive number is always greater than a negative number, then the cosine of A is greater than the cosine of B, which would contradict our original statement. The second statement is sometimes true as well. Here's my logic. If A is chosen such that the blue line is shorter than the red line, in other words, the sine is less than the cosine, then the tangent will be less than 1, thus contradicting the statement. By contrast, this picture shows that the statement can be true because in this picture, the blue line is longer than the red line, and therefore the ratio of the blue line to the red line, which is the tangent after all, is going to be greater than 1, and thus the statement can be true. The third statement is never true. The cosine of any value can never exceed 1. That's just a fact. The fourth statement is also never true because the cosine squared of A plus the sine squared of A is always equal to 1. That's an identity we know, and therefore it could never be less than 1 if it's always equal 1. The fifth statement, it turns out, is always true. And I'm going to try to provide a proof to you of that right now. Here's the statement that we want to prove. I've just recopied it up here for juxtaposing purposes. But notice the arguments don't match. We've got a cosine squared of A and a sine squared of B. So here are the thoughts that went through my head to convince me that this statement is always true. Notice this is an always true statement. But also notice I've changed one of the arguments so that they're both A. And we know that cosine squared plus sine squared of any given number is going to equal 1 if the arguments match as they do here. So how am I going to use the fact that this thing is equal to 1 to prove the line above it, which is the one I want to prove? Watch and you'll see. What I did was I replaced sine squared of A with sine squared of B in this equals 1 statement. Now I would contend that by replacing sine squared A with sine squared B, I've replaced that term with something smaller than that. And if I and I'll I'll give you the rationale for that in a moment, but if I can prove that I've replaced a term with something smaller, then this sum, which used to equal 1, must now be less than 1. And that will complete the proof if I can show the smaller comment that I made here. So here's my logic. We were given that the sine of A is greater than the sine of B. Squaring both sides of this equation tells me that the sine squared of A is greater than sine squared of B. And therefore, sine squared of B is smaller than sine squared of A, thus completing the proof. But really, it's worthy of a comment here. The fact that these are both positive numbers was essential in my ability to square both sides of this inequality. Because just because one number is bigger than another doesn't mean the square of the first number is bigger than the square of the second, unless they're both positive. Here's a counterexample to that. What if we took the statement that involved negative numbers? 3 is greater than negative 5, but 3 squared is not greater than negative 5 squared. So it really was essential that these were both positive in order for me to assert that I could square both sides of this inequality and still have it be true. And because sine squared b is smaller than sine squared a, that completes the proof of this statement and tells you why this statement is always true. And that completes this problem.